Now let's apply the same process to the coin tossing example. You remember that Patriots won 20 out of 25. They won 19 coin tosses. So if we calculate the proportion P hat, they had 19 successful outcomes out of 25 experiments. So it's 0.76. In 76% of the cases, they won the coin toss. And the question is, for a fair coin, so fair toss should be 0.5. And the question now, if we calculate the confidence interval for the Patriots proportion for the 0.756, the question is 0.5 inside confidence interval for P hat, the proportion of the wins in the Patriot coin tosses. So let's calculate the confidence interval. This is P hat plus minus 196, and this is P hat times 1 minus P hat divided by n, which is 25, and the interval we get is 0.6, 0.92. So given the observations, given that we saw 25 observations, the confidence interval does not include, so the answer is 0.5 is not inside the confidence interval. So we should say that the way we're going to interpret this finding is that it's very unlikely that this outcome happened by chance, but it still might have happened by chance. It's just unlikely to happen by chance. That's all we can say here. All right, so let's do the conclusions. There's a number of things we can say here. First thing is that estimates are based on random samples and therefore random uncertain themselves. And when we talk estimates, we're talking about estimates of the mean in this case. And we need to account for this uncertainty in the estimated mean. So if we take, if we go from one experiment to another experiment, from one group of people to another group of people, the means that we calculate from those experiments, from the measurements, can change because of the sampling error. And the standard error measures the uncertainty of an estimate, so it tells us what are the bounds likely for the errors in our estimates due to the sampling error. And we can construct 95% confidence interval using the fact that the mean itself follows normal distribution. We know how to estimate the center of this normal distribution and the standard deviation, which is called the standard error of the distribution. And this provides us with a plausible range of for the quantity we are trying to estimate. So we can calculate 95% confidence interval or 99% confidence interval, depending on how confident you want to be about the conclusion.